students, this is Mrs. Shaima Gharib and today's lesson about comparing and ordering fractions. Let's revise some rules before you watch any video. You have to sit in a quiet place. You should have your pen and a piece of paper to take notes and to solve questions. You should pause the video after each question, then you try to answer on your own. Then you play the video to check your answer and to understand the question in case you get a wrong answer. Are you ready? Let's start our lesson. Comparing fractions with same denominators. We have two fractions here. Both of them have same denominators. Let's read these fractions together. 2/5 and 4/5. Can we read them in a different way? Let's see. We said before that we can read them as 2/5 and 4/5. What do you think? If you have 2/5, which means 1/5 and 1/5. So they are 2/5. What about 4/5, which means 1/5 and 1/5 and 1/5 and 1/5. What do you think? Is 2/5 greater or smaller than 4/5? Of course, it's smaller because I only have 2/5. Let's see by a diagram to make it more clear. This is the 2/5, 2 parts out of 5 parts, and the 4/5, 4 parts out of 5 parts. So now, what do you think? This part is smaller than the shaded part here. So, of course, 2/5 is smaller than 4/5. Let's see this. If we have two fractions, but this time they have same numerators. The first fraction, 1/5, and the second fraction, 1/8. Can we read them a different way? Do you remember when we said that we can read it as 1 divided by 5 or 1 divided by 8? We're going to use this now. If you have one chocolate and you want to share it among 5, and you have one chocolate and you want to share it among 8, so what do you think? Which one will get the biggest part? Of course, when you share it among 5, the part will be bigger than if you share it among 8. So 1/5 or 1 divided by 5 is greater than 1 divided by 8. Let's see the diagram to make it more clear. This is one part out of 5 parts. And this is one part out of 8 parts. And notice that the one whole here is exactly the same as the one whole here. Now look at the shaded part. Look at the 5ths, 1/5, and look at the 1/8. It's very clear that this part is greater than this part. So 1/5 is greater than the 1/8. So what did you notice here? When we have two same denominators, so the smallest numerator is the smallest fraction. When we have same numerators, so the smallest denominator is the greatest fraction. Okay? Now, comparing fractions with unlike denominators. Look at these two fractions. They both have different denominators. When I have two fractions with two different denominators, so first step I have to do is to change the denominators to be the same. I have to change the denominators to be the same. How can I change denominators to be the same? First, I will think, can I find an equivalent fraction for the 2/7, for example, and change it into a fraction over 5? Can I multiply the 7 or divide it by a number to make it 5? No, I cannot. So I need to think of an equivalent fraction to the 2 over 7 and another equivalent fraction to the 3 over 5. And these two equivalent fractions must have the same denominators. How can I do this? I have to think of the least common multiple between the two denominators here. So I need to think of the common multiple between 7 and 5. And it's better to choose the least common multiple or the first common multiple. Okay, so what do you think? How to think of the least common multiple of two numbers? I will start with the biggest number, which is the 7. And what should I do? I have to think of the multiples of the 7. Let's recall the multiples of 7 together. The first multiple is 7. Is 7 multiple of 7? Yes. Is it multiple of 5? No. So I will move to the next multiple. Is 14. 7, then 14. Is 14 a multiple of 7? Yes. Is it a multiple of 5? No. So I will move to the next multiple. 7, 14, then 21. Is 21 a multiple of 5? No. So next multiple will be 28. Is 28 a multiple of 5? No. So the next multiple will be 35. Is 35 a multiple of 5? Yes. And it's a multiple of 7 as well. So this is the common or the first common multiple between the 7 and the 5. So my common multiple will be 35. Now, after this step, I have to change denominators into this common multiple. So how to change the 7 to be 35? I will multiply it by 5. And what should I do next? I have to do exactly the same with the 2. Multiplied by 5 equals 10. So 2 over 7 equals to 10 over 35. Now I will change this 5 to be 35. So how to change the 5 to be 35? Multiply by 7. And I will do exactly the same with the 3. I will multiply it by 7 as well, which is 21. So now 3 over 5 equals to 21 over 35. Now both fractions have same denominator, which is 35. Can I compare now? Yes. I will look at the numerators and compare. This is 10 and this is 21. So 10 over 35 is smaller than 21 over 35. So the first fraction, which is 2 over 7, is smaller than 3 over 5. And please, when you compare fractions, don't use the butterfly method because it's not recognized by Cambridge. Comparing fractions with unlike denominators. If I have two fractions, 2 over 3 and 3 over 8, what did we say? Denominators must be the same. So I will think of a common multiple between the 8 and the 3. How? By recalling the multiples of the biggest number, which is the 8. 8, is it a multiple of 3? No. Then 16, is it a multiple of 3? No. Then 24, is it a multiple of 3? Yes. So this will be our least common multiple. So now I will change both denominators to be 24. 3 to be 24, I will multiply it by 8. And I will do exactly the same with the 2. So it will be multiplied by 8, which is 16. Then I will do the same with the second fraction. I will change this 8 into 24. How? Multiply the 8 by 3. And I will do exactly the same with the 3. So it will be 9. Now I have two fractions with same denominator, which is 24. 16 over 24 and 9 over 24. So 16 over 24 is bigger than 9 over 24, which means 2/3 is greater than 3/8. Okay, is it clear? You have to follow these two steps to be able to compare fractions. Now, let's see another question when we have more than two fractions and we want to put them in order. Order the following fractions in descending order. What's the meaning of descending? So you have to start from the biggest fraction to the smallest fraction. Okay? Now, I will look at the denominators. They are different. What did we say? Denominators must be the same. Now, I will look for the multiples, the common multiples between the three denominators. I have 2, 6, and 3. What do you think? How to get the common multiple between these three numbers? I will look at the biggest number and start count on by this number and find out. 6. The first multiple of 6 is 6. Is 6 a multiple of 2? Yes. Is 6 multiple of 3? Yes. So my common denominator, which is a common multiple between the three numbers, will be number 6. Now I will change the denominators to be 6. 2 to be 6, I will multiply it by 3. 1 will do the same exactly with it. 1 times 3 equals 3. The 5/6 will stay as it is because it's already over 6. Now, I will do the same with the second fraction. 2/3, the 3, I want to change it to be 6 by multiplying by 2. 3 times 2 equals 6. Then I will do the same with the 2. Multiply the 2 by 2. 2 times 2 equals 4. So now I changed all denominators to be 6. I can order now. I have 3/6 and 5/6 and 4/6. And we said we have to start from the biggest one. So the biggest one here is 5/6. So it will be written first. Then I have 4/6. Should I write 4/6? No. And take care of this point. When we list the fractions, we have to write the fractions in the question, not the equivalent fractions. So I will write 2/3 because this is the fraction in the question. Then 3/6. Should I write 3/6? No, I will write 1/2. As we said, we write the fractions that mentioned in the question. Okay? Let's see another example. 4/5, 5/8, and 3/4. I have three different denominators, 5, 8, and 4. And we said denominators must be the same. So how I have to think of the common multiple between the 5 and the 8 and the 4, the least common multiple. How? I look at the biggest denominator, which is 8. This is the biggest denominator. Then I will start to recall the multiples of 8. The first multiple of 8 is number 8. Is 8 a multiple of 5? No. Then after 8, 16. Is 16 a multiple of 5? No. Then 24. Is 24 a multiple of 5? No. Then 32. Is 32 a multiple of 5? No. Then 40. Is 40 a multiple of 5? Yes. Is 40 a multiple of 4? Yes. Then 40 is a multiple of 5 and a multiple of 8 and a multiple of 4. So this will be our common multiple between 5 and 8 and 4. Then I have to change denominators to be 40. 5 to be 40, I will multiply by 8. And I will do the same up with the 4. 4 times 8 is 32. Then 8 to be 40, I will multiply by 5. And I will do the same with the 5 up. 5 times 5 is 25. And the 4 to be 40, I will multiply by 10. And I will do the same up. 3 times 10 is 30. Now I have 32 over 40, 25 over 40, 30 over 40. And the order here should be in ascending order. What's the meaning of ascending order? Ascending order, I have to start from the smallest to the biggest. So which fraction is the smallest here? It's 25 over 40. Should I write 25 over 40? What do you think? We said we write the fraction in the question. So I will write 5 over 8. Then 30 over 40. And I will write the original fraction 3 over 4. Then 32 over 40. And this is the biggest one. So, and I will write it as 4 over 5. And please don't forget to write the fraction that mentioned in the question. Okay? Thank you. Now, questions time. Are you ready? Let's go. I have here 3 fractions, 8 over 9, 2 over 9, and 5 over 9. Order the following fractions in ascending order. Ascending means start with the smallest fraction. We said denominators must be the same. They are already the same, so I will order directly. The smallest fraction here is the fraction with the smallest numerator, which is 2 over 9. So I will write 2 over 9 first, then 5 over 9, then 8 over 9. Let's see. Next question. Order the following fractions in ascending order. 3 fractions with 3 different denominators. What did we say? Denominators must be the same. 3, 4, and 6. I have to think of a common multiple between the 3 and the 4 and the 6. How? We choose the biggest denominator, which is the 6, and we start to recall the multiples of 6. The first multiple of 6 is 6. Is 6 a multiple of 3? Yes. Is it a multiple of 4? No. So I will go to the next multiple of 6, which is 12. Is 12 a multiple of 3? Yes. Is 12 a multiple of 4? Yes. Is 12 a multiple of 6? Of course. So my common multiple between 3, 4, 6 will be number 12. Now I will change all fractions to be over 12. 3 to be over 12, multiply by 4, down and up. 2 times 4 equals 8. Now 2 over 4 to be over 12, 4 times 3 equals 12. And I will do the same with the 2. I will multiply it by 3. 2 times 3 equals 6. The 6 to be 12, I will multiply it by 2. And I will do exactly the same with the 5. So it will be 5 times 2 equals 10. Now I have 8 over 12, 6 over 12, and 10 over 12. I will start to arrange them in ascending order, which is start from the smallest fraction. The smallest fraction here is 6 over 12. Should I write 6 over 12? No, we said we write the fraction in the question. 2 over 4. Then 8 over 12, which is 2 over 3. And the biggest one is 10 over 12, which is 5 over 6. Okay, is it clear now? Let's go to the next question. Nada says 3/5 is smaller than 4/10. Is Nada correct? Yes or no? And show your work. In this question, to compare these two fractions, I will do the same. I will try to change denominators to be the same. How? By using common multiples. I have 5 and I have 10. I can change the 5 to be 10? Yes. So I can multiply this fraction by 2 up and down. Why by 2? Because 5 times 2 equals 10. Now, 3 times 2 equals 6. And 5 times 2 equals 10. So I have now 6 over 10 and 4 over 10. Is 6 over 10 smaller than 4 over 10? Of course, no. So my answer will be no. Why? Or show your work or explain. I will exactly write these steps. I will change this 3/5 into an equivalent fraction over 10. I will say 3 over 5 equals 6 over 10. And I will show the steps like this. Multiply by 2 up and down. Okay? And I will say that 6 over 10 is greater than 4 over 10. All right? Then I will say that the 3/5 is greater than 4 over 10. Is this clear? So you have to follow these steps in such type of questions. Now let's go to the next question, our last question. Put each fraction in the correct place in the following diagram. I have 2/3, 3/8, 7 over 9, 12 over 24, and 5 over 5, and 9 over 18. In the diagram, I have 3 places. Smaller than half equals to half, greater than half. Do you remember in equivalent fractions how to compare to the half? We said something about the half. In any equivalent fraction of the half, the number up or the numerator always have the number down. So I will look at each fraction here and think, is it greater or smaller than the half? The first fraction is 2 half of 3? No. What is half of 3? Half of 3 is 1.5, right? Is 2 greater than 1.5? Yes. So this fraction is greater than half, so I will put it in this place. What about 3 over 8? Is 3 half of the 8? No. So is 3 greater or smaller than half of the 8? What is half of the 8? Half of the 8 is 4. Is 3 greater than 4? No. Is it smaller than 4? Yes. So this fraction is smaller than half. Now, 7 over 9. What is half 9? Half 9 is 4.5, right? Is 7 greater than 4.5 or smaller? It's greater than 4.5, of course. So this fraction will be greater than half. So I will put it here, 7 over 9. What about 12 over 24? Is 12 half of 24? Yes. So this one is equal half. So I will put the 12 over 24 here in the correct place. What about 5 over 5? Do you remember? The fractions equals to 1 whole. This fraction equals 1 whole. So is number 1 smaller or equal or greater than half? Of course, it's greater than half. So 5 over 5 will be placed here in this place. What about 9 over 18? Is 9 half of 18? Yes, of course. So this fraction is equal to the half. And I will put it here. Now, I put all these fractions in the correct places in this diagram. This is the end of our lesson today. I hope you enjoyed the video, and if you have any question, please feel free to leave a comment and I will answer you as soon as possible. See you next video, and please remember that your feedback is highly appreciated. Thank you very much and see you soon.